Hey math fans, test 17 lesson 5, get your swords ready and let's go. Today is mostly a review. We're going to identify prime and composite numbers, we're going to identify possible outcomes, and we're going to write theoretical probabilities as percents. So let's start with a quick review about prime and composite numbers. So remember, prime numbers are divisible only by themselves in 1. All other numbers are composite numbers. So look at this little, I don't know what it is, it's not a chart, a schmoz of numbers. Which of the numbers below are primes? So just look at them for a minute and try to figure out which ones are primes. So here are your prime numbers. 13, 37, 29, and 2 can all be divided only by themselves and 1. Notice that 1 is not a prime number, it's a special number. And our last two outcomes we're going to do together. I can identify possible outcomes and I can write theoretical probability as a percentage. Those are going to link up in our next question. So Reed and Sue try an experiment. They mix different chemicals in 2 beakers. When they are finished, the chemicals could either turn red, blue, green, yellow, or brown. What is the theoretical probability that both beakers will turn the same color? Give your answer as a percent. So I have to be able to do 2 things in this question. I have to be able to list possible outcomes, and then I have to be able to give the theoretical probability as a percent. So here are my options. Chemical 1, chemical 2. I'm going to make a little chart. If chemical 1 turns red, chemical 2 could turn red, or it could turn blue, or it could turn green, or it could turn yellow, or it could turn brown. There's all my possibilities if chemical 1 turns red. If chemical 1 turns blue, chemical 1 could turn red, or it could turn blue. I need another chart. Or it could turn green, or it could turn yellow, or it could turn brown. I should put BR for brown just so I can keep track of it. Next up, I can go to, so I did red, I did blue, now I'll do green. So if chemical 1 is green, chemical 2 could be red, or chemical 2 could be blue, or chemical 2 could be yellow, or, I skipped green, whoops, chemical 2 could be green, or chemical 2 could be brown. Okay, so I'm done green. Next up is yellow. If chemical 1 is yellow, chemical 2 could be red, or it could be blue, or it could be green, or it could be yellow, or it could be brown. And just one more left to do. I'm going to have to write a little smaller for this one. If chemical 1 turns brown, chemical 2 could be red, or it could be blue, or it could be green, or it could be yellow, or it could be brown. So those are all the possible outcomes. Now next up, I'm going to look at which ones will turn the same color. That's my question that I'm being asked. So let's take a look and see which ones turned the same color. So there was red and red, there was blue and blue, there was green and green, there was yellow and yellow, and there was brown and brown. So the possible outcomes that turned, or the possibilities of everything turning the same color were 5. I kind of need some more room here. I'm going to get rid of this picture. So the outcomes were 5 out of, how many total outcomes did I have? I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So the theoretical probability that both beakers will turn the same color is 5 out of 25. To write that as a percent, I'm going to do 5 divided by 25 on my calculator, and I am going to find out that that gives me a probability of 20%. If you're really on the ball here, you may have also noticed that 25 times 4 is 100, and 5 times 4 is 20. And we're done. So, your review for today, number 1, what are the prime numbers in the list below? And number 2, if you draw a card from a deck of regular playing cards, what is the theoretical probability of getting a heart? Write your answer as a fraction and a percent. So get those done, and I will see you tomorrow.